This is my recent LinkedIn post where I describe the early career struggle of discovering what I want to research. At first glance, it seems like I should study, and the dream is to join Google DeepMind or OpenAI. But the problem is, I might get stuck into their machinery of them telling me what to research, which I may not believe in. For example, what if LLMs are not the answer? I mean, LLMs are good and to some people they feel like AGI already, but what if it's some other architecture like JEPA or some other architecture that has reasoning, more reasoning, better reasoning, memory, hierarchical planning? So I believe that first I need to discover what I believe in, what I believe the future of AI is. And if I believe it's LLMs, then I should look to join OpenAI or DeepMind or whatever. But I currently think that I should first try to figure out even a better architecture. And if I'm successful, then it will lead to either me starting my own laboratory or joining or persuading some other laboratory to let me work on this or something like that. But right now, the first I need to find out what I want to research, what I want to work on, what my vision is, and because if I don't have a vision, somebody will impose their vision, and when somebody imposes their vision, you cannot do research. Or that's how I feel like when somebody tells me what to research, I just see no purpose, and if I see no purpose, I see no path forward. So let's try to figure out what could the potential architecture and path forward for superintelligence be. I will scroll here, but that's not the main point here. So on top of LLMs, we need some kind of reasoning or abstract planning. So my idea is to try to come up with a very general algorithm, and even if it's a very big model and very complex model, if there is such a thing as a better architecture, and even if it takes me 5 to 10 years to make significant progress, then that's still worth it, and that's the best thing that could happen. So let's think about how this general architecture for general superintelligence would look like and what improvements are there on top of LLMs. At first, my idea was to give it all kinds of data, text, video, and especially video. We are looking with our eyes, and all of the knowledge that we have, a lot of it is just learned from other people. For example, other people's emotions, when you look at them, they are representing reality. So if somebody is mad at you, that's because your actions could result in something bad later in the future. So I feel like when we look at other people, look at their body language and look at the words they say, they are expressing compressed information about reality. So we can learn from that as well. So we learn from other humans, we learn from books and from videos and from watching. So I think, and on top of that, I wanted to maybe even add simulations. You know how we have reinforcement learning algorithms that use simulations, like robotics simulations. But then after that, I thought of just making an AI that still has all of this planning and memory on top of all of the other things that LLM has. But this AI would just be for designing better AIs. And now I don't need to have AI to learn everything about everything, like saltiness of the sea or wood properties, just about designing better algorithms. But this would still be a very vast or vast enough knowledge. So I'm still building a very big generally super intelligent model. Potentially that's like the goal if we are trying to figure out how to achieve super intelligence. So this model would still be very good mathematician and programmer, And on top of that, for example, the way I imagine is it reasons somehow in latent space without using tokens. So tokens, I believe reasoning with tokens is just a discrete sequence to sequence, but maybe this model can reason and plan somehow in latent with latent vectors, transformations, and maybe do some parallel traversing of latent space. And when I say traversing, I just mean sequentially calculating, going from one vector to another, which is what LLM does. So so I guess traversing like LLM means sequentially, but maybe some different, or we can have a bunch of parallel traversing's, not just one like LLM, or we could have some different types of hierarchies. So all of this would be like a hierarchical planning and thinking. But I haven't thought too much about this. But the idea is to build this very complex, or to aim to build this very complex system, because we need to start somewhere. We have a blank canvas. We have an advantage over OpenAI and DeepMind and other companies. They are stuck with LLMs. Yes, they might do some research on the side, but they don't have blank canvas, and we do. So we can think of the next generation AI model. So I'm just thinking about this architecture that superintelligence will have. So, and I guess the task of creating better or AI systems like that would include writing CUDA code, Triton code, uh, PyTorch code, but before that it would include reasoning in abstract space. And I guess I wouldn't have tokens in abstract space. I would have abstract representation of tokens, which is usually a lot less data. So instead of predicting entire sentence word by word or token by token, there can be just a lot simpler concept that represents that entire sentence without necessarily having all of the details of which exact words are used to express that thought. You can just have the thought without having unnecessary, unpredictable details. So this would remind me of JEPA architecture. So I guess JEPA architecture is already something like this. I don't know if it has memory. I think it doesn't have memory. So what is a memory? I'm thinking memory is something that is not used, that is very rarely used in computations. Only a single part of it is used rarely, every now and then. So that's memory. So we need to add this part to the architecture so the architecture can somehow store new thoughts or opinions. But I also read a lot about brain, and the brain, it's not like neural networks. Brain is firing discretely a bunch of neurons, and each neuron is not, it's not like a vector embedding where vector embedding is a concept, but depending on which combination of neurons fire, we get a concept. So this is completely different. It's like a group of neurons firing, and also it's contextualized. So apple will mean different things to you when you are hungry and when you are full. So these are all of the things I'm thinking about. And then I was checking DeepSeek Prover v2. How do they prove these mathematical theorems? But I think our architecture is different. So we are not necessarily even proving these theorems. We are just having some abstract reasoning and generating some code. So then the other idea is same as in AlphaGo, the amplification and distillation. So when we have this model, we do something like Google does with Alpha Evolve. So we just use it to generate a bunch of different codes and then have some evaluation system automatically measure the best code and find a lot of best data like that, and then use that data to to improve the model, to train the model, to improve the weights. So we are using more compute to find better equations or code, and then we are training data on only the model on only the best data. So that's amplification and distillation, using more compute and then distilling it. And the thing with this is that the better your model, the better and faster it will make better data. So it grows exponentially on itself to a certain extent. The limiting factor could be architecture or the amount of data or compute you have, etc. Probably usually architecture, I think. So I think right now only thing for me to do is to try to figure out this JEPA architecture and maybe think about this further, which I will do tomorrow and maybe make another video. So thank you for watching and see you next time.